Hey everyone, today we will learn how to mesh an equal T-pipe junction. The equal radii intersecting pipe geometry is represented by two cylinders of radius 1 mm intersecting each other. We will start with a 2D wireframe and extrude it to 3D. In this tutorial, you will learn how to build topology if we have intersecting pipes of the same radii, and secondly, how to create copies of topology by rotation. The case has two cylinders representing the pipes and planar surfaces at their outer boundaries to form a closed volume. Here is a 2D wireframe for one arm of the pipe. I have grouped the two interior interfaces into two separate groups. Using transform rotate with copy options, I will rotate the topology by 90 degrees. The same steps has to be repeated for angles 180 and 270 to create wireframe for the full domain. If we check the groups where interfaces were added, the new interfaces are also appended to it. This will help in merging them together. I'm going to add both these interface groups into a new group and merge them to form a connected topology. Next, I copy the wireframe to both sides of the 2D section. With this, we have completed a base wireframe. Next, we can assign the face to each of the pipe surfaces. I'm moving ahead to the assignment step before creating an O-grid because it is sometimes easier to visualize with fewer blocks. To create an O-grid, we will group the outer faces, excluding the pipe outlet and inlet planes, and create a wrap. With this, we have completed the block building and the assignment step. The next step is to check the validity of the topology. The check reports a mildly singular topology at the intersection region. This is caused by the sharp intersections between the pipes. To fix the movement of blocks around the intersection, I have created two disc-shaped surfaces which are perpendicular to each other and pass through the intersection curves. To freeze the faces to the surface, I will assign the group of faces emerging from the intersection curves. Check for the surface assignments to ensure the surface defined as interior surface. Now let's check the validity again. The validity shows a valid topology with no singularities. If the grid solver is run for about 1000 sweeps, we can notice that the surface folds have reached zero. We can load the grid down after the zero surface folds and check for volume folds. We can notice that we have a zero surface and volume fold grid. The mesh generated is of very good quality with a max Q value of 0.65. To view a section of the grid, we can create a slice through the block. With this, we come to the end of today's tutorial. If you have any questions on the steps or any comments, feel free to leave it below. If you want us to post tutorials on any specific geometries, you could write to us on support@gridpro.com. Thank you for watching. If you like this video, leave us a like and subscribe to the channel for new videos. Follow us on our social media pages. The links are posted in the description.